Hello everybody, this is a video lesson series on price elasticity of demand. The objectives of this lesson are to understand the meaning of the term price elasticity of demand, to define, calculate, and interpret numerical values of elasticity, to explain the relationship between price elasticity of demand and total revenue, to apply the concept of elasticity to economic contexts, for example, in the incidence of taxation and the incidence of subsidies, to show an awareness of the factors which influence price elasticity of demand, and to understand that price elasticity of demand varies along a straight line, downward sloping demand curve. So let's get started with this. So to begin with, I'd like you to read through these 5 different examples and describe as precisely as possible the relationship between the following variables. So just pause for a minute and just have a look at those and just either note down in notes very quickly or just think about them and then unpause in just a minute and we'll go through them. All right, I hope that's enough time for you to have a look at that. So to just go through them, when a bicycle is set at low gear, each turn of the pedal crank will turn the wheel half a time. In other words, it takes 2 turns of the pedal to move the back wheel once. Compare that to number 2. When a bicycle is in high gear, each turn of the pedal crank will turn the back wheel 2 times. So I think that shows the responsiveness of the back wheel turning to moving the pedal. When you're in very low gear, you turn the pedal around several times, the crank around several times, and it only barely moves the back wheel. That helps you get up hills, but it means the back wheel is not very responsive to you turning the pedal. But if you put it into high gear, for example, if you want to go really fast down a hill, you turn the crank once and maybe it turns the back wheel several times. That means that it's more responsive. That's my interpretation of it anyway. Number 3, a grown man who weighs 80 kilos will eat 120 grams of spaghetti for a meal. His 5-year-old son weighs 20 kilos and eats 60 grams of spaghetti. So really the question here is, who eats more spaghetti? Now you might say, of course, in absolute terms, the grown man eats more spaghetti because he eats double the amount of spaghetti, right? He eats 120 grams of spaghetti. But if you wanted to say proportionally, his son, who only weighs 20 grams, eats 60 grams of spaghetti, you might work out that actually, proportionally, his son eats more spaghetti because as you quadruple the weight of the people, go from 20 kilos to 80 kilos, you could say that actually the amount of spaghetti eaten only doubles. And so therefore you might say that the amount eaten is not very responsive to changes in the mass of the eater, because as we've quadrupled the mass of the person eating, we've only doubled the amount of spaghetti that's being eaten. I really like this idea of proportionality, of thinking about the grown man eats more in absolute terms, but proportionally to the weight, the boy is actually eating more. And we've worked that out by looking at actually how many more times is the weight of the grown man compared to how many times is the actual weight of the meal. And as we've seen, that actually proportionally the boy would eat much more spaghetti. These last 2 here also have something to do with a bit of responsiveness. It takes a very small amount of force to push a toy car 2 meters across a wooden floor. It takes much more force to push a large stone across the same floor, or to push the stone the same distance. That's because a toy car with its little wheels would be very responsive to a bit of force. So you tap the toy car and it moves across the floor, but a stone takes a lot of force, and so therefore you might say that the toy car is much more responsive. Same thing with a rubber band. If you take a rubber band and flick it across the room, if you pull it back 10 centimeters, it'll flick across the room. But if you take a piece of string, pull it back the same distance, it will barely fall off your finger. That's because a rubber band is very responsive to a little bit of being pulled back, whereas a piece of string is not very responsive at all. These are good exercises to look at because that's what elasticity is all about. It's the responsiveness of one variable to another. And that's what we're going to look at in just a minute. So, what is elasticity? Elasticity is the responsiveness of one variable to a change in another variable. Change one thing, say the weight of the eater, and how much does the other variable, say the amount of spaghetti eaten, change? That's what it is. Try to keep it very, very simple. If we say what is price elasticity of demand, then it means this is the responsiveness of quantity demanded following a change in price. So if we change the price of the product, how responsive is the quantity demanded? It's a good time to mention the idea of proportionality, which is a very, very important way of speaking when we're discussing price elasticity, or any type of elasticity for that matter. If demand is price elastic, that means that quantity demanded changes more than proportionally following a change in price. If demand is price inelastic, it means that quantity demanded changes less than proportionally following a change in price. It's very important to understand that elasticity is simply measuring that responsiveness of something, of one thing to the other. But a very correct and technical way of speaking about elasticity, and the way that I would definitely recommend that you speak about elasticity in your exams, is to use that idea of proportionality, is to say that if something is elastic, you change the price, and therefore it changes the quantity demanded more than proportionally, which is what, and we're going to see how it is that we can define that. Same thing with if something is inelastic, we change the price, and the quantity demanded will change less than proportionally. It will still change, but the percentage change, the proportional change, is less. And that's a very, very good way of describing that. How will quantity demanded react to price changes? Now, we've already talked about demand, and we know that the law of demand states that if the price goes up, the quantity demanded will go down. And likewise, if the price goes down, the quantity demanded will go up. That's to do with the income, substitution effects, and also because of diminishing marginal utility. And we know that therefore we can call this a negative relationship. As one goes up, the other one goes down. Elasticity measures the strength of these changes. So we know that for price elasticity of demand, with a downward sloping demand curve, it will always be negative. But what we're interested in is if we change the price a little bit, if the price goes down a little bit, how much does the quantity demand change? And this one here on the left, the price change affects quantity demanded more than proportionally. Small change in price down, large increase in demand, quantity demanded going up. So we would call this side elastic. On this side here, the price change affects quantity demanded less than proportionally. A very large fall in price, a relatively small increase in quantity demanded. Therefore, we would call this inelastic. The way of measuring this, we can measure it mathematically and numerically by using this formula. The formula for PED is the percentage change in quantity demanded over the percentage change in price. You can always put it into shorthand descriptions. You can use formulas and say that PED is the percentage delta triangle, which means change, in QD, quantity demanded, over percentage delta triangle, which means change in price. And what that means is a silly way that I think about it, is to say that the queen rules over the people. Because if you remember that, you can always remember that Q goes over P. The reason why this formula is really cool and a neat way to measure price elasticity of demand is because it already puts proportionality built into the formula itself. When we're measuring a percentage change in something, as we are when we measure percentage change in quantity demand, that's different from measuring an absolute change in something. So if we change our quantity demanded from, say, 10 to 12, that would be an absolute change of 2. But 2 is an absolute change if you go from 10 to 12, or 20 to 22, or 100 to 102. It tells us nothing of the proportionality. But if we measured it as a percentage change, if we go from 10 to 12, that's a 20% increase. And that's proportional to the original value of 10. If we go from 100 to 102, it's still the same absolute change, but a much smaller percentage change. It's a 2% change from 100 to 102 because it's in proportion to the original number. And that's why this formula is a really clever way of measuring price elasticity of demand, because it's always, from the start, measures proportional changes, which is why we can always say that something is elastic if it has a more than proportional response. So, the first type of question that you might see using this formula. Say that the price of a rice increases by 10%. This has the effect of decreasing the quantity demanded for rice by 5%. What is the price elasticity of demand of this product? Well, to work this out, we say our price has gone up by 10%. The quantity demanded has gone down by 5%. The price has gone up by more than quantity demanded has gone down, by proportionally more than quantity demanded has gone down. This makes this a bottom-heavy fraction. We can say that quantity demanded on the top here is unresponsive. The price elasticity of demand is therefore minus 5% because it's gone down, divided by 10%, and dividing that through means that our price elasticity of demand value is minus 0.5. I will say that this is a bottom-heavy fraction, and because it's a bottom-heavy fraction, because the denominator is greater than the numerator on top, this is going to have a value, when you divide it through, of less than 1. The value of that number is less than 1. Say the price of oranges decreases by 5%, and this has the effect of increasing quantity demanded by 7.5%. So let's work it out if this is elastic or inelastic. So we know that the price has gone down by 5%. The quantity demanded has gone up by 7.5%. We would say that the quantity demanded has gone up more than proportionally compared to how much the price has gone down. So price has gone down by proportionally less than quantity demanded goes up. This makes it a top-heavy fraction. Quantity demanded, as we could say, is responsive in this case. Plugging this into the formula, 7.5% divided by minus 5% means that our price elasticity of demand, or PED value, is minus 1.5. This is a top-heavy fraction, which has a value of more than 1, and therefore we would say that in this example, oranges are price elastic. They are responsive, more than proportionally responsive in quantity demand to changes in price. Before you start working on price elasticity of demand calculations, it's worth reviewing the percentage increase and decrease formula. And this is really the most maths that you need to be able to succeed at A-level economics. As long as you can do percentage change, you are well away with your maths skills. So just as a review, the percentage change formula is the new minus the original divided by the original times by 100. The times by 100 only means that you're making it into a percentage. Now, there are many other different ways of tricks of doing this, but if you don't feel very confident with those other tricks, you can always use this formula, which will give you the correct value. So with whichever method you feel most comfortable, have a go at these questions here, these price and customer and sales changes, and see if you can just tell me what the percentage increase or decrease is. So pause the video, have a go at these questions, and we'll review in just a minute. Okay, Hopefully you've had a go with those. So if you look at the first one, price increasing from 100 to 110, that represents a 10% increase. 10 divided by 100 times by 100. The next one, customers decrease from 300 to 240. That represents a 20% decrease. 60 divided by 300 times by 100. The price decreasing from £30 to £20, that is a 33.3% decrease. Of course, if we just round to the nearest decimal place. And that's because it's 10 divided by 30 times by 100. Or if for number 4, the number of sales increase from 200 to 260, that is a 30% increase because it is 60 divided by 200 multiplied by 100. So hopefully you found this pretty easy, and there'll be plenty more time to practice some more questions like that. All right, let's look at an example question then. Suppose a firm increases price from £40 to £50, and sales then fall from 200 per week to 180 per week. You might be expected in an exam to say, what is the price elasticity of demand? Is this elastic or inelastic? And what will happen to the firm's revenue? Now, using this information, we'll then try to make up a rule that links elasticity to revenue. So let's have a look. So first of all, what is PED? We have to first work out the percentage changes. So first of all, working out the percentage change in price. It was a increase in price from £40 to £50, a difference of 10 divided by the original of 40 times 100 is a 25% increase in price. The percentage change in quantity demanded, it started from 200 and went down to 180. So that's a minus 20 divided by the original 200 times by 100, which will give us a 10%, a minus 10% change in quantity demanded. So we can then use the formula. PED is equal to percentage change quantity demanded over percentage change in price. The queen rules over the people. Plug those numbers in. Minus 10% divided by plus 25%, which gives us a value of minus 0.4. This is a bottom-heavy fraction. 25 is greater than 10, and that the figure of 0.4 is the value of 0.4 is less than 1, and so therefore we would say that this product is not responsive to changes in price. It is an inelastic product. So, is this product elastic or inelastic? We would say that this product is inelastic because the PED value is less than 1. That is to say, the PED is between 0 and minus 1. The demand has changed, but it has changed less than proportionally compared to price. Now, what should have happened to the firm's revenue? We should expect this to go up. The firm has increased price, but demand has only fallen a little bit, which is to say less than proportionally. So it is selling almost the same number of customers, but each customer gets charged a higher price, and so therefore we would expect proportionally fewer customers, more than proportionally higher price will mean that we have an increase in our revenue. What will happen to the firm's revenue? Well, the old revenue, the old price and the old quantity, £40 times 200, £8,000. The new revenue is £50 times 180, and that works out to £9,000. So the rule linking elasticity to revenue is that because the revenue and therefore the revenue has increased. So what is the rule linking elasticity to revenue? Well, as we've seen, we had an inelastic product and we raised the price. So therefore, if the product is inelastic, raising the price will increase revenue. If the product is elastic, then raising the price will decrease revenue. Let's try a few other exercises. So for each of these questions, do the following. Calculate PED, state whether the product is elastic or inelastic, calculate the old revenue, and then calculate the new revenue. So if you just pause the video, and we'll review those in just a minute. Okay, hopefully you managed to do those. So look at the answers here. For question number 1, looking through this, here we go. So the PED for question number 1 was -2. That means it's an elastic product. The old revenue was £500. The new revenue was £360, and this makes sense because the price has gone up, the PED is elastic, and so therefore we would expect, with the price having gone up, that the revenue would decrease, and that's what's happened. For question number 2, the PED figure is -2.5. The old revenue was £600, and the new revenue is £720. So we've seen an increase in revenue, which is what we'd expect, because the price has gone from 15 to 12, a decrease in price, elastic PED, which would therefore mean that we would expect the revenue to increase as it has. Looking at question number 3, the price elasticity of demand is -0.5. This means that this product is price inelastic, and the revenue has gone from £2,000 to £2,160, which is what we'd expect, because they've raised the price from £25 to £30. The product is inelastic, and so therefore raising the price with a product which is inelastic will increase our revenue. And finally, with question 4, the PED value is -0.25. The old revenue was, this makes it inelastic. The old revenue was £1,200. The new revenue is £1,008. That's a decrease in revenue, which is what we'd expect because we have decreased our price. The product is inelastic. Quantity demanded is not responsive to changes in price. The quantity demanded has increased less than proportionally compared to the percentage change in price, and so therefore we would expect to see a decrease in revenue. So the general rule for the relationship between elasticity and revenue is because revenue is equal to price times quantity sold, you can work out what the effect of a price change will be by considering how responsive or unresponsive your product is to a change in price. So with elastic products, using this formula for revenue, if we have a decrease in our price, we will see a more than proportional increase in the quantity demanded or quantity sold, which will mean that when we multiply that together, it will actually increase our revenue. Whereas with inelastic products, if we raise our price, this will have a less than proportional impact on quantity sold. And so the large arrow up multiplied by the small arrow down will still increase our revenue. So the other way of saying this is to say that with elastic products, if you want to increase your revenue, you should decrease your price. With inelastic products, if you want to increase your revenue, you should raise your price. I often like to think that it's a good idea to have an interpretation of the numbers for PED values, and I often like to put them on number lines. We'll be looking through the other types of elasticity, and I think it's very useful to put them onto number lines to be able to interpret what type of elasticity that product has with a particular PED value. Now the first question is, what are the possible numbers that a PED value should be? What I mean by that is, what are all the possible range that they should be able to be? Now, I would say that all price elasticity of demand values should be negative. They should all be below 0. That's because of the law of demand, assuming that if the price goes up, quantity demanded goes down, or if price goes down, quantity demanded goes up, that is a negative relationship. And so therefore, I would always interpret PED values to be below 0. If they fall in this zone here, between -1 and minus infinity, this means that they're going to be top-heavy fractions. The value, which is to say the absolute value of the number, is greater than 1. I know that it gets confusing because minus 1.5 is less than -1 on the number line, but the value 1.5 is greater than 1. So that's what I want you to think about, the absolute value of that number. It's a top-heavy fraction. The numerator is greater than the denominator. The queen rules over the people, so the percentage change in quantity demanded is greater than the percentage change in price, which means that these are responsive products. They're responsive to change in price. On this side of the number line over here, the value is less than 1. These are the bottom-heavy fractions, where the percentage change in quantity demanded is less than the percentage change in price. Because of those figures, we say that in this section here, between -1 and minus infinity, these are the responsive section. These are therefore the price elastic section. So anything between -1 and minus infinity is price elastic. So for example, a PED of -1.5 would be an elastic product. If you have a number which falls in this range here, between 0 and -1, that means it's unresponsive. We describe that as being price inelastic. And so an example of that would be a PED of -0.5. That is a bottom-heavy fraction to give us 0.5. And so therefore, those are the inelastic products. The final thing you might want to do is have a number line which just describes all the possible names for types of elasticities. If the PED is 0, you say that's perfectly inelastic. There is no response change. If you change the price, the quantity demanded does not change at all. So perfectly inelastic. Inelastic, as we've said, describes those unresponsive types of products where they don't change very much with price. The quantity demanded doesn't change much with price. -1 is a special case. It's called unit elastic. It means that the percentage change in quantity demanded varies completely proportionally to percentage changes in price. Elastic, as we said, is responsive. And so that's in this value here between -1 and minus infinity. And then if you wanted to call something perfectly elastic, that would mean that it has a PED value of minus infinity. And we'll talk about the situations that you might have something like that. It's also useful to be able to relate these to different types of demand curves and what the demand curve is going to look like depending on the elasticity for the product. If we have inelastic demand, this is not a perfect way of describing it, but a general way of describing it. With inelastic demand, quantity demanded is not responsive, it's not sensitive to price changes. Therefore, as we change our price quite a bit, we don't see very much movement in quantity demanded. This means that we've got a nice steep line here, still downward sloping, but a very steep line. And the way I think about it, the way I remember it, it's a bit silly, but you say that looks kind of like an I for inelastic. If you have elastic demand, this means that quantity demanded is very responsive to price changes. So we change our price just a little bit, and we see wide changes in quantity demanded. So that means it's not a very steep curve. It's fairly flat, and it looks kind of like an E. My other silly way of remembering it is it kind of makes the middle part of an E. So therefore, we can call that elastic. Last thing to look at then, if you wanted to categorize the number line into different types of demand curves, we could say that the perfectly elastic one is a perfectly not steep demand. So the price is set. Any deviation from this price will cause the business to lose all of its customers. So as an example, you might say like wheat or potato farmers, anyone that's selling a commodity where the product is the same as every other competitor's product, you might say is going to be perfectly elastic. We've seen as well that you have elastic products where it sort of looks a bit like it's a bit, well, it's a bit steeper than perfectly elastic, but it's still not very steep. Quantity demanded changes more than proportionally following changes in price. We're not gonna, I'll show you where we can actually have a unit elastic PED, but you wouldn't really call it any kind of linear demand curve. In fact, any curve which is straight line, you call it a linear demand curve. And we'll show you later on in other lessons about how it is that price PED changes along the curve. You can then also have ones that are inelastic, with a very steep, looks like an I. And then if something is perfectly inelastic, it just means that it's perfectly straight up and down. No matter what the price, the demand will be constant. If you charge a higher price, you're not going to lose any of your customers. Right. So we'll leave it there. I'll put the other learning aims in some other future videos, but I hope you found that very useful. If you did, please make sure that you give it a like, subscribe, or leave a comment, and stay tuned for more economics content from this channel.